Welcome, .NET friends. It's another episode of the On .NET Live show. You know what we do here. We really strive to empower the community, to inform you of what other folks out there are doing with the .NET tech stack. As usual, I'm your host, Scott Addy, and I'm joined by Myra Wenzel and Cam Soper. We have a very familiar face on today's show as the guest, Swamy. Swamy, many of our viewers are already familiar with your presentations from the past, but could you please introduce yourself for folks that are new to the show?
Hey guys, this is Swamy. I am very passionate about learning a lot of new things. I call myself as Swamy the Learner. So I give this title to myself. No one gives. So I always love to learn new things and speak about whatever I learn. And thanks to all those industry experts from whom I am learning, I really appreciate them for sharing their knowledge. Back to you, Scott.
Yeah, so speaking of always learning new things, my understanding is today we'll talk about ChatGPT. Seems like I can't go anywhere these days without hearing ChatGPT. Whether it's the local grocery store or picking up the kids from school, someone's talking about it. And my understanding is today we're going to build something like that in .NET. So where do we want to start this discussion, Swamy? I know you had an agenda you wanted to walk
Yes, here is the agenda. I'll just quickly, could you please flash my screen?
Yeah, it's there.
Okay, thank you. So today's agenda, as I was mentioning, Swami the learner. I'm still learner. Apologize if I do any mistake. And here is what you already boarded a express train. So please fasten your seatbelt. So first we'll start with a little bit of discussion. This all will cover in 5 to 10 minutes because the terms are already there. And thanks to ChatGPT, from where I did the straight lift of these paragraphs and pasted it here, condensed version. So we'll speak about these terms and then we'll go through some of the visual images to understand what is that we are speaking about and where we will be going from here. And then we'll speak about Eliza, which is the world's first neural network, neural language processing. This is the first AI or artificial intelligence program which was developed in 1960s to 64. We'll speak about it, and then we'll come back to Azure OpenAI and what is transformer and what is GPT, and then we'll speak about tokens. Why should we learn about tokens, and then we'll try a couple of completion using Azure Studio, get our fundamentals strong in that, and then we'll come back and learn under the hoods thing. What is that? Because when we do it in Studio, it is wrapping up or it's abstracting. It has the question and it gives the answer, but we don't know what is happening under the hoods. So this program will get us up and running under the hoods. We will see some of the bits and pieces we'll learn here, and then we will start building our own chat GPT in .NET 8. And some of the beautiful things in .NET 8 I've learned is about this. I'll speak about those things also. I'm very energetic to speak about those points. Back to you, Scott.
Yeah, so I think maybe a good place to start here when we're talking about something like ChatGPT is what category of technology does this fit into? And what I mean by that is, as a developer who isn't, data science focused, you often hear the terms artificial intelligence, machine learning, deep learning. The list goes on and on. What's the relationship between all of these categories?
Okay, so if you see this one over here, we can that we will speak about the intelligence. Like we as a human, we learn from different things like our experience, our senses, and based on our previous data, whatever we have seen, that's where we develop intelligence. Like whether we ate some food and we are getting allergy, so we know that we should not eat that food and relative food. So that's what the intelligence we are learning. So artificial intelligence is something, a program which has been fed with a lot of data and it behaves similar to the human. So the next subsection is the machine learning, where we'll collect a lot of data and bifurcate, select an algorithm, and divide the data into 80 comma 20. That's the standard. It's not hard and fast rule, but we'll make it 80 comma 20. Feed in the data to this algorithm and train it. Once it has been trained, we'll use the 20% of the data to see how it is performing, the model performance. And if everything is good, that's when we'll go ahead and push it onto the production. And it's a iterative process. If it is not performing well, there is an edge case. Again, we need to come back and retrain it. And one of the finest thing in training these OpenAI ChatGPT models is that there are billions of data, lot of data, and billions of parameters. By seeing itself, I was thinking that wow. And the deep learning is another subsection within that. And I have piled up quite a few terms here. Let me quickly go through this one. Like artificial intelligence refers to the computer science where it behaves similar to the human intelligence. Like machine learning is subset of that involves the development of algorithms. If you see that We collect the data, we'll massage it or prepare the data, then we'll select the model, we'll train again 80 comma 20, we'll evaluate and do the performance, the parameter tuning, and then we'll leave it for prediction. And this prediction is for the machine learning. Like if it comes to the generative artificial intelligence, instead of prediction, it creates a new content. So deep learning is subset of machine learning, as we were seeing in all these diagrams. If you see artificial intelligence, machine learning, deep learning. So the deep learning is where, again, it has got a lot of things within it. It's a subset of the machine learning, and it has got many neural networks. We can see that. So natural language processing is one thing, and if you see the generative AI, that again has got a lot of sections like generative adversarial networks and variational autoencoders. That all we will see here, like autoencoders, CNN. A lot of these things are coming in terms of that. So if these are the minimal terms we need to know if we want to jump into ChatGPT. Back to you, Scott.
Yeah, so I think that was a really nice overview of what the different terms mean. So to kind of like take that a step further, what if we were to talk about a real world use case of something like machine learning? Um, Personally, I think of possibilities like anomaly detection, maybe in a manufacturing line where you're trying to find the defects in products that are being produced. But I imagine there are numerous other use cases. Is there one that's top of mind for you, Swami?
Oh yes, pretty recently, one of the engineering college where I went for discussion on the latest technologies. So that's when those students showcased one of their product, or the demo which they created in Python. So what did they use is, in some country they have the water plant, so they'll fill the water in those cans. So what these people did is they used the images of the filled in water cans, and they improvised the images again using Python, and then they found some of the dirt or a small worms or any anomalies inside that. So those kind of things are very very important. Like if you go see a small insect or something dirt which is there inside the can, and we don't catch it and we sell it, and the customers drink, they will fall sick, or the reputation of the company will be at stake. So those are machine learning nowadays is machine learning or artificial intelligence nowadays, it's coming everywhere. So this is one of the real time scenario. What I was telling is the real project which they developed. Apart from that, there are a lot of other uh, things, but this is top of my mind, Scott.
And then I know another thing you had mentioned. Thanks for providing that example. Another thing you mentioned was NLP, natural language processing. Um, I know you had an example of this you wanted to share. Was it the Eliza project?
Yeah. Yes. So Eliza, we were thinking that artificial intelligence or NLP was started pretty recently. No, it goes back to 1960s. So this gentleman at MIT, he created this program back in 1960s, and it came somewhere around 64 to 1967. This program is called Eliza. I got a hold of this program in Go language, but I didn't get this program. But that is pretty fantastic. I tried that program in Go language. It was almost pretty similar to the ChatGPT bot, where I interacted with that Go program language. So I was feeling that wow, we didn't even know that these kind of programs were existing. It was very simple pattern matching, and I saw that it's a small array and a bunch of statements in Golang, but it was answering lot of things until we said quit. It was answering. I said that, wow, this is seriously a lot of industry experts, as I was mentioning. So thanks to everyone who created a lot of knowledge for us. Back to you, Scott.
Yeah, thanks for sharing that example. So, as I'm watching the chat here, I'm seeing a lot of chatter, people all over the world tuning in. But one of the things that I wanted to point out is you've mentioned other programming languages like Python, like Golang. When you think of things like AI and ML, you could probably survey 100 people, and most of them wouldn't mention .NET. But we're noticing that starting to change over the last couple of years, especially. Um, and today you're going to show us how to build something like this with .NET. But before we get to that, I wanted to ask about, there's this other buzzword that folks are hearing out in the community, and it's OpenAI. Could you talk to us about what is OpenAI and what is the relationship uh, that Azure has to OpenAI?
Oh yeah, sure. So one second, let me open AI. So this OpenAI has started as an open source product, and they created a lot of these generative models. So, and after that, they have to support a lot of these projects. So it became full-time job for many of those programmers who were giving it as part of the open source, and that's where they have to convert this into a company, and they're charging it. And there are a lot of other companies which invested in this, and I read somewhere Microsoft was also one of the biggest uh, contribution in from the investment perspective, from the research perspective also. And exclusively Microsoft Azure is giving access through Azure to OpenAI. As of now, I think Microsoft Azure is the only one cloud provider who gives exclusive access to this OpenAI. And this has many models. And I right now I don't want to derail the session, but you can see that there are a lot of models, and each of those models, when we get deep into the weeds to find out how much data with which it has been trained, and how many parameters it's going into, 117 millions and somewhere millions of parameters with which they have been trained. So seriously, that much amount of fine tuning, as well as injecting the data and getting it trained. And those are showing right now. If you see that the model which we are using is a completion model, but it is a latest version of the API.
Now, as we're looking at this list, we see different versions of the GPT model. I assume the larger the number, the newer the model. If you were to explain to the audience what you're going to do today, are you going to be basing this off of GPT-4?
Good question. So if you see this is the Azure OpenAI resource which I have created, and the first thing we will play with the studio, and inside this studio we will be going through a couple of these things. And again, I'll come back to your query on the models. Will set up the context. If you see that the models, whatever we have here, we can create the deployments. We can go here and we can see all the models. Each of the models, if you see, has got trained with different content, and that's one thing. And another, different parameters. If you ask the same query to text DaVinci 3 versus either the text query or text adder, it will give different results. In one of the demo, I showcased it live. So it gives different uh, different results. And that does not mean that it was not trained properly. It is 100% that we have to communicate the way it understands. So that's where our skill set of prompt engineering will come into the play.
I had a real quick
So
question. Swami,
yes,
I had
sir.
a real quick question.
Yeah.
So how do you know which one of these models that you want to use for a specific task? I mean, is there some guidance somewhere, or is it just like trial and error?
Oh,
ChatGPT, dude.
the here, if you see that at the first glance, we can see that for images we will use this, for audio to text conversion we'll use this, for set of text to numerical form, like these kind of things we use it. And if you see that whether we have to use the base GPT or 3.5 or GPT-4, we two things will come into the picture. One thing is the pocket, what is going to get charged, or if I'm able to do the same job with 3.5, I'll stick to the 3.5. So one is the functionality which is being provided, and other one is how much I'm going to be charged. And if I'm purely looking from the charge perspective, I might not get the good results. So each of those models are specifically designed for one job. So we have that. And then another thing is, if we go deep into that, into those models, this the max tokens and its capability will come into the picture, and the training data also. Because if you take any of those, let's compare with this one itself. If we take ChatGPT 32K versus ChatGPT 4 versus GPT-4 32K, the max tokens are 32,000. That means it's like you're hitting an API endpoint, and API endpoint is giving you a JSON. Assume that it is going to give you 32,000 bytes, and this model is going to give you 8,000 uh, 8,000 bytes. So that is different. So the more the tokens, you will be able to ask a tougher question, or which gives a lot of content. If you see that 8,000 characters versus 32,000 characters, something like that. So these all things will come into our picture.
But I saw really quickly when you were entering Azure AI Studio, there were some descriptions with some models, and I don't know if on the drop, like I don't know if it was on the, it was like
Here,
yeah, but that is like when you're looking, that is not very descriptive. So like if you hover on the select a model, does it have some explanation of what those models are on the,
oh,
on the information there?
oh, here it will. Those models we can go deep, and we will be able to find out like what is that at this, or we can directly go to the Azure OpenAI site. Here in this we have the models, and they have given pretty much lot of information, and we can get into this. It clearly shows that what is that it supports. Yeah, we
So
will
that's
get.
where you see that name that matches the thing that is in the drop down. Yeah.
Yes, it will. We will
But
find all these.
I saw like in 2 screens ago, 2 or 3 screens ago, like I think it was in the opening screen of the Azure AI Studio, that it has some descriptions of what you could do and the models that he used. I don't know if it was on that first home tab or
Yeah.
something there, where
Yeah.
it's like saying like chat playground, and you can experiment with chat GPT 3.5 turbo or 4 model. So like here you kind of have an overview of what some of the things you could do to get started.
Right. Right. To get started, like I can go to this this one, and I'll say that create apple with blue. So I can give some prompt, and it pretty quickly it creates apples with these colors. Sometimes it almost matches as if it is real apple with these colors. Now see this. I mean, it's.
That's
I
pretty.
didn't ask it. Whatever the colors I put it created it. It's. I have to fine tune this one. So whatever. Yeah. Any other queries?
One more question. Earlier, you were talking about a concept called tokens, and I just want to make sure the audience is clear what we mean by that term.
Yes.
I guess in the simplest terms, a token could represent a single word in a sentence. Is that accurate?
Actually, the tokens, there is an algorithm. So for English, approximately 4 characters. We will do the calculation. Approximately 4 characters. We'll see that. Before that, I'll take real quick minute of these things. Azure OpenAI is a service like we saw that just now. It is giving access to the OpenAI, and Transformer is the model's name. So GPT is generative pre-trained transformer. Okay, generative means it's creating and it has been pre-trained, and transformer is the underlying model or NLP. So there is a tool called tokenizer. So you can click on that and we'll be able to come into this one. So this is a sample text for Scott. Okay, so as here it mentioned somewhere as approximately 4 characters. This is for English. So 100 tokens is approximately plus or minus 75 words. So there is an algorithm why it is breaking that way. We don't know. But if you see that alphabet A and space, this is being considered as 1 token. But if you see sample and space, these are 6 plus 1, 7 characters is being considered as 1 token. Each different color represents 1 token, and we will be charged based on the number of tokens. So these number of tokens is the prompt which you are giving to this model and the response which it is generating. So we need to be mindful of that. So that is what we are going to be charged.
So you mentioned cost, and so as an independent developer, and now all of a sudden I get nervous. How do I know what something like this would cost me to use?
Okay, so from the costing perspective, it is detailedly given in the documentation. What is that it is going to be charged, and somewhere is there in the documentation pricing here. So we can get into that pricing, and we can calculate this one. If you see this, what is the model, and per 1,000 tokens, what is that we are being charged. So we can almost, if not accurate, 5 or 10% plus or minus here and there, we will be able to get that. The detailed pricing is here, and we know that the tokenizer tool is pretty handy for us to find out what it is. With these 2 things, we can accurately come to a conclusion that this is what we will be charged.
That's really helpful. Yeah. I looked at the pricing. It looked like GPT-4 was it 6 cents? I think I saw. If we go back to that page.
I'm flashing it again. And again, these things are available only in few regions. So the charges might vary. I'm really not sure on that. But whatever we are seeing is here. So GPT-4 is 6 cents per 1,000 tokens.
Got it.
And
so for the price of a Dogecoin, you could use GPT-4. A lot of people talk about this in terms of going without a Starbucks for a day. I chose to take that a different direction. Cool. So we're about halfway through the show. I'd like to find time to get to your demo.
yeah,
Why don't we
sure.
start digging into that?
Yes. So first I want to set the context. Uh, we'll use the Azure playground. Then we will go ahead and see that a small demo in C Sharp. That's to find out a little bit of under the hoods, and then we will come back to the main chat GPT program, whatever is our main goal for today. So if you see that, we'll give the prompt and we'll get the answer. And here, one thing to understand is if I exclude this and again I click on generate, we see that it's going to give us a new joke. It's not going to give the same joke. That's because the parameter, one of the parameter which is driving is this one, the temperature. If I make the temperature to 0, that means the randomness or the creativity will be lesser. That means it's going to stick to the game plan. Like any number of times we hit that, it's going to give the same joke. We innocent mushroom and innocent carrot, at least those two words I remember. If I hit this for the second time, it's going to give us the same joke. So that's one important point. And the max token is we can restrict just to be on a safer side. So this is just the playground is there. Not all people will have access to this one. Assume that we have a team, and that team or a project team, they have to use this. So we can't, or they might not have access to this, or giving them the token and the endpoint might be a little bit risky. So one of the motivation why we can create our own GPT just for our team and hook it up with the Azure AD. So only our team members will be able to log in and do this prompt engineering or get their queries answered, maybe scientific or regarding the human resource or regarding the coding or any of those things. And the key thing is we don't need to sweat on anything. Azure has given tons and tons of coding. And here also you can click on view code. You have this, and you can see that you have Python, you have curl, you have JSON, and you have C Sharp. And it's C Sharp is also pretty much detailed code. And here will be the key, and we will be able to do that. So this is the first demo. Just wanted to set the context. But here what is happening is we are not knowing what is happening under the hoods. So that is the reason first we will comment. We will see this is one more simpler thing. It's just a straight lift from Azure Microsoft documentation. A little bit tweaking I did this. One more thing to observe here is these two things. In .NET 7 and 6, 7 and 8, somewhere in these, they have introduced. So if you see this in the entire program, we will not see console, a word. And we are not even seeing that using static system.console. Nowhere we are seeing this. So what is happening under the hoods is if we go into this debug and get into the global usings, go into this global.
I see it there. I think it's
here.
third from the bottom.
Yes. Yeah. If you see the global usings, there, whatever we instruct as part of this, it gets added to the global usings. So that is one of the suggested way to add this. And this is aliasing. We are doing aliasing. So here what is happening is there are multiple files, 2-3 files are there, but nowhere I'm going to add the static. So the suggested way is to use this. This is from Mark J. Price, .NET 7 and .NET 8 book. I just learned it from there. So let's come back to understanding the deep into the weeds. One important point is here, always the app settings, we can use it, but we never know that when we will check it. So what the suggested method is to use the secrets. So right mouse click on this and manage user secrets. That will add the secret.json. We need to put it. Or another method is mark this as non-trackable and create app settings.example.json. Write down what all the things it needs. So that way, what will happen is any of our team members will be able to use it. And something which is very secret and you're using it at multiple places, create an environment variable. So that also I gave it in the documentation. Create, so those things which are pretty secret, create an environment variables. Now nowhere in the app settings.json or .env files, nowhere it can be traced. It will be there as part of the environment variables. So this is a simple configuration builder, and here is a model. So just before printing all these things, I just wanted to show you under the hoods. Then we'll go and create the project from scratch. I will just give it a minute. The box is slow or what? Okay, so if you see that the response object is here, I will do a quick watch on this one. And if you see that this is a raw response, we can see that what is that it is going to give. And inside this content, we'll see the content stream and other things. But our interest is here, value. And choices is an array. At this point of time, choices is 1. And the usage statistics, it says that how much it's being charged for the prompt. Prompt itself is 21 tokens, and the completion is 106. So total 127. So this ID is being tracked. The time is when it got created, and the choices of 0. And inside that there will be text. And the finish reason is very important thing. Sometimes the finish reason will be stop, and this stop can be I'm completing the job and I've completed. That means that will be stop. Sometimes what happens is, if you go back to the if you go back here, there is a stop sequence. Here we can define that whenever you see mushroom, stop it. So I can put this here. Whenever you see mushroom, you stop it. So this could be one more reason why it will stop. Oh, sorry. Looks like I forgot to click on that. And whenever you see mushroom, you stop it. You saw that it's not going to generate anything of that. So the stop reason could be 2 things. One is, hey, I've completed my job. That is one reason. And another reason stop could be because we have given the stop sequence. And sometimes the length itself will come into the picture. Suppose if I say that the max tokens is 20, so it was costing 127. Now if I say that the max tokens is 20, so at that time the stop will be the stop reason will be length. Okay. And another important thing what we need to understand is, sometimes when we say that n means what happens is, it will create n number of the output. So we are going to charge for the total output. That means whatever this max token 120 we are telling, this is for one response. If you said that generate me 10 responses, like create a tweet on my dosha center which I'm opening, or a fast food center, create 10 tweets, I will select best out of that. So here I'm saying 120 tokens is for one tweet. If it creates 10 tweets, that means 120 into 10, it's 1000 plus. Okay, so we need to understand that. And if we say that n create n equal to 2. Okay, so generate sample count. This is the n. Now I'll put a debugger here. I just want to set the context. This is very very important point. I will show you in the Python program or somewhere I created it. We'll see that. But let me jump onto that. But I'll tell you 2 things.
And here in the program, he used a different input, right? Like it was a different input that he used in the Azure AI Studio, right? That you were counting the tokens and everything.
I'm sorry, I missed your last sentence.
On the program, you're using a different input. It's not the jokes one. It's a different question, right?
Yes, this is the one. What are the top 10 countries here?
Okay.
So this
Yeah, and
is
if
the
anyone
one.
has
Let's see the output.
questions, yeah, if anyone has questions, feel free to ask them now in the chat, and then when we have a chance, we'll ask Swamy.
Okay, that is one sample. I just want to show the another sample also before we jump into the main program, whatever we'll be discussing. This is a little bit different program. This is where the prompt engineering is also going to come into the picture. So it's not restricted to one prompt. We can have multiple prompts. So let's see that program real quick. And in this program, what is happening is the same program, whatever we have seen in this previous desired output. I'm saying that give me as part of JSON or give me as part of XML. There's nothing different here. So two things I will highlight. I'll better show that in Python programming. But let me show this and where this completion or whatever we are doing, where will it come into the picture? So this output, whatever we are seeing here, this will give us a clear-cut direction where we can use it. Okay, looks like okay, right. That's what I was expecting. I'll get it from here. Copy this and come back and put it here all the way till here. And that's the okay. One important thing is this one, the deployment name. Whatever you have deployed, that name is the one which it is asking. So sometimes you see that different programs, different sample codes, they are calling it in a different name. They're saying that model name or model deployment name, but technically whatever we have deployed in Azure, that is the model name we have to give. The endpoint, the model name, and the key. Those are the key things. Now see this. This is where as I was mentioning, the prompt engineering will come into the picture. See, if we used the old mainframe model, the fixed length string, we can ask that, hey, give this output in a fixed length string. Or someone who has got a contract with this, they can ask it for JSON. Give me the output as JSON. Now I can parse this JSON. This is a collection of countries, population, and city. I have a data transfer object. I will transfer this and use it. Some legacy services, SOAP over XML, web services, ASMX web services, we can use these XML and speak with them. So now coming back to our program, we will see that this is the one. So there are a couple of things I will speak here. This is being done in .NET 8 and also in minimal API. So these things I've already covered, aliasing and this one. The benefit of this, you will see that I'm using this constants in different places. In these two different endpoints. In welcome endpoints, I'm using these constants, but nowhere I'm telling that where these constants are coming from. And because I've marked it here and it's getting into the global JSON, I can use it across the project. Okay, that's one tip I wanted to give. Another one is aliasing also we can do. And this aliasing we did it, and the static also we discussed about it. And the second important thing is we are seeing a new file in .NET 8 template. And this file is the It's based on one of the extension, which I see that this one REST API extension. You can see that it's almost similar to this one. It supports, see that exactly. You can create whatever the way we want, the post, get anything and everything, we can create it, and we'll be able to test it. We don't need any other tool. Like the Visual Studio Code itself has got so many tools. You don't need to go out of this tool. Everything is being provided. So similarly, this is fantastic tool. We can write the code, we can write the testing here itself, and we can debug, or we can send the request and we'll see the output on the right side. That is another tip. And let me come back here. Now, this is some of the technical jargon. They call it as a big ball of mud versus all-in-one architecture. This is like an all-in-one architecture, and I wanted to keep it this way. We can, from here, we can go to the layered architecture or different architectures we can go. This is one thing. And the second thing is the separation of concerns. Like many authors, they say that if at all a file has to change, it should have only one good reason. So if it is changing for A and B, that means it's not maintaining the separation of concerns. So for that reason, there are multiple ways to do it. I did a small refactoring. If you see that, I just wrote a simple extension method here, and this extension method itself is having all the configurations. The service container is getting configured into this. So if at all I have to do anything with the service container, all I have to come and modify this file, nowhere else. That's one point. And here, if you see that, I'm configuring the request response pipeline. The difference between the controller and minimal API is the minimal API will have lesser number of dependencies. That means in your backpack, you're having 10 LBs in minimal API. Assume that if it is controller API, you might have 25 LBs in your backpack. So your memory, you're lifting a lot of weight. And the pipeline, if you see that, it's a shorter pipeline. It's like we are using this and this and this and this. I think in my previous discussion, when I was doing the minimal API one, I went deep into the weeds to showcase the difference between how the pipeline itself is going. So this is from the separation of concern perspective. Now, if you see that our program class is pretty simple. And another thing is we want to wrap up the UI also within this. Technically, we can have, by exposing this minimal API, we can have different clients. I can write MOI to have the mobile application which talks to this, and React, Angular, Blazor Server, Blazor Razor, ASP.NET Razor Pages, or traditional MVC, anything. So by writing this, we can have it. One more thing is, if you see that while I created this extension method, I used iService collection. If I would have used the builder, web application builder, I don't need to write this line. Everything will come into this one. So technically, if you see that one line, this 1, 2, 3, 4, and 5, within 5 lines, the program.cs has been wrapped up, and that too with separation of concerns. Okay.
Swamy, I wanted to chime in real quick. We're at about the 15-minute mark, and I know you had another ChatGPT sample you wanted to get to.
Oh, that is this is the one.
This one, okay.
Yeah, this is the one. So if you see this common, so all the constants, there are no magic strings around anywhere in this one. So whatever the magic strings are there, it's there here. If you see that these are partial classes, both are representing the endpoints. So again, if you see this, this is separation of concerns and minimal impact on other files. If I have to change the endpoint name, all I need to do is come and change it here. Nowhere in the endpoint, if you see that in Azure OpenAI endpoint, nowhere we have that. So that means even though you go and modify some of the file, it's having two things. One is separation of concern, and the impact of modifying something in this file on the solution or on the project is very low. If I change it, nothing is going to change. Only the client. If Moi is using, Moi has to make the change in the endpoint. So these constants, I learned it from Steve Smith. He said that put it in a class and wrap all your constants like this and create multiple classes. .NET 8 or maybe Visual Studio or Visual Studio Code, I don't know who suggested. He suggested that all these two files were in the same file under constants and different classes. But it suggested, the IDE itself suggested to have a partial class and move it into separate files. So again, this is again a beautiful way to organize and minimizing the impact of our changes. Okay.
Yeah, Steve Smith has a very popular session on our YouTube, and I'll try to find a link about clean architecture. It's like one of our most popular videos on the channel. So yeah, you can check it out. Why Codes is also like just to go to the basics for some of our beginners. Like he's asking, what I'm hearing the minimal API. How does it differ from web API? So can you cover a little bit of that? Otherwise, we can.
Oh yeah, we did this in the previous session, but I will definitely cover this real quick in the same series itself. Here, in this series, we have covered that piece. Let me go to the documentation so that I'll be able to speak much better.
Yeah.
So if you see that, as I was mentioning, two things.
Go ahead.
There will be two things which will impact or which will come into the picture. So I will directly go to that section where I was showing the differentiation, parameter binding, and HTTP pipeline. Yes, this is where. So one thing is, if you come and put a debugger here in the program.cs, just give me a minute. This will answer your query. Let's wait until it hits the debugger. Okay, now when we start any of the line, there are 127 dependencies. Now we have to load this in memory. So what if you compare the web API, the controller, full-blown controller API versus the minimal API, just before you start the builder.build, at this line, if you put the debugger and compare both, whatever you're adding on top of that and whatever it is coming out of the box. So the number of services which loaded in the container are more. That means this is from the memory perspective. And from the HTTP pipeline perspective. So HTTP pipeline perspective, here if you go and see these two URLs, and then just watch the previous video, it is there. So if you see that, it's in this one. So, wow, I think it's this one. Here, yes, this is the one. If you see that, each of these middleware will have some seconds, like maybe milliseconds or nanoseconds or whatever. It consumes some time. So if it is a full-blown controller, how many of these middlewares you will add it to your controller? It will be definitely more than minimal API. So if you see the minimal API in the previous video, I clearly shown that it comes to the request and directly goes and hits the endpoint and send the response. But here in our case, whatever we are seeing is, let's go to this application services. I'm sorry, this is the request response pipeline. So if you see the request response pipeline, we are using Swagger. That means one, which is common, and exception, this is common. This will be common. Static files is this middleware. and we are just adding endpoints. That means these things are not there. So it's like whether you're eating a plain pizza or you're adding additional toppings. So the request response pipeline, whether the pipeline is longer or shorter, that's where it differs. So
Yeah, like just to like summarize, like in minimal API is still like you're building web APIs, but it's like a more straightforward way to build web APIs with your code, because you remove all of that scaffolding, all of that structure that you have to do in the past to create a web API, and you can see that the code is much cleaner. And so that's one of the beauties of having minimal API, and that's why we call minimal, is because it's like a small way to build those web APIs. So,
but it is powerful.
mhm.
Correct me if I'm wrong.
But
So
it's just easier to write because you remove all of that middleware code that you had to do before, and you go straight to like the routes and the endpoints that you had to do.
exactly. So we can see
Swamy,
that. Yeah.
we a quick time check here. We've got about 7 minutes remaining. There is one thing I wanted to dig into. I know I'm curious. It sounds like some of our viewers are as well. I know you're using the OpenAI client library that the Azure SDK team ships.
Right.
Could we look at your CS proj file and just point out what dependency that is that's being used?
Oh yeah, sure. I just wanted
Because I
to
think
show you
that's
this.
the glue that's kind of making all of this work. And I want to make sure folks understand what's going on behind the scenes. And maybe we could show how you're creating the client object from that library.
Yep, sure. So if you see that, Myra, this one will also help them. If you see that at this point, here is the request, we received it here, and see that it's directly going to the endpoint. There are no middlewares between the request and it goes, hits the endpoint, and then it spits out the response. So the shorter middleware, the faster response. And if you see that here, we are having Azure OpenAI, azure.ai.openai, and this is the library which I'm using. And in the repository, if you see that repository, it is the same one. We'll create a OpenAI client. We will pass the endpoint, which is again coming from the application insights. And OpenAI key I created as an environment variable so that I don't need to save in this app settings or in the JSON file or env file and worry whether did I check in or not. And the model deployment name plays a very crucial role. If we give something else, some of the samples they call it as model or different things which I've seen. But it's a model name. This is how we create the client, and await client dot call the method get completion async and the deployment name. And this is the completion options. And in the completion options, if you go and see at the top, you will be seeing different things, choices, everything is, this is equivalent to end. This is what I told. So we can tell something in two different ways. I can tell that, tell me two jokes on innocent people. That means N. I can tell as part of my prompt, or I can tell that, tell me a joke. And choices per prompt is, I can specify two. That means what happens is it will generate two choices. In that case, I need to go and iterate the choices. At this point of time, whatever we considered is the choices is one. I ask a question and it gives me a response. But this is N. Echo is another thing where we need to be very careful. That means it will slightly increase the number of tokens, because I ask a query, it gives me a response. And if I see echo, that means it is going to spit the query what I asked. So we're going to be charged slightly, because apart from our response, even the query is being spit out. And another thing is, this one stop sequence I spoke and I've given an example also. Another thing is It's called as, I'll tell you what it is called from the UI or from the Python perspective. If you see that, best of. So best of means what happen is, internally it creates 10. If you say that best of 10, tell me two jokes. So what is happening is, it is going to create 20 jokes, and out of that it takes one, this whatever is our input. So if you say 10, so 10 into two jokes, so 20 jokes it creates. So we are going to get charged for that one. Okay, so this is our repository, and if you see that, let's see how it works. We have 2 minutes, and I have this code checked in. I will give the repository. I'm going to or that repository I'll give you, so that it will be pretty much handy. Keep it, this one is a tree where I have all the source code and everything here. So we'll see the Swagger we have seen, and because we have included here, we see that it is plain HTML, JavaScript, and CSS, nothing else. So if I come to the sources, you can see that it's index.html. Bootstrap is coming from the CDN, and have a CSS file and JavaScript file. And the CSS file is pretty simple, and that is, I'm having Google Fonts, so that's another thing. And the scripts is very simple scripts. So whatever we are doing, we are using this fetch from JavaScript, and we are calling the completion, passing in the user input, and whatever the response it comes, that's being processed here, and we are maintaining two different things. So let's see this in action. I'll open this and keep it as part of this response. I say that what is an apple, and click on that. We'll see the network tab, and you can see that the network tab, we were hitting the API endpoint, whatever we have seen in the Swagger, and payload, we passed it, and we see that because I said echo to true. So what is happening is, the input which you have given and the answer which it is coming, both will come out. So that means we are going to be charged for these tokens. And again, the query is coming as part of the response. So it's like a double charge for the query. Okay, so what is generative AI? And I'll click on that. So it's just simple to have a query and answer, like a simple thing. The motivation, or why do we need to do this, is someone who doesn't have, but they need to speak to the ChatGPT or this completion models. If we hook this up to Azure AD, only the team with which we'll give access to that enterprise application, only they'll be able to log in and they'll be able to access. Whether they are programmers or non-programmers, everyone can use it. Like, we build it and others can use it for programming query or anything. Back to you, Scott.
Yeah, thank you. So unfortunately, we have to wrap things up. Real quick, though, I wanted to point out again, this is the Azure OpenAI client library that Swamy's been demonstrating. He's using the beta 8 version, which has been out about a month now. So kind of sort of hot bits, come at those with oven mitts on. We do expect that library to reach GA in the near future. So what you saw today will be stable in the near future, and you should be comfortable using that in your production grade applications. I do want to thank all of our viewers for tuning in. Thank you for your continued loyalty and all of your questions in the chat. As a reminder, you can check out our live stream recordings out at dot.net/live. And if you tune in next week, we'll be joined by guest Victoria Dolzenko, who will join the show to talk about building a scheduling system with background processing based on Postgres. So do tune in next week and check that out. Thanks to Swamy, and thanks again to everyone for tuning in today.
Good night, folks.
Bye.
Bye.
Bye.